To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Right, children. Under this chapter, we are going to learn about the second method of heat transferring through substances. Okay, that is convection. So I explained y'all in the previous chapter that there are three ways of heat transferring through substances, that are conduction, convection and radiation. So earlier chapter we learned about conduction. Conduction is the method of heat transferring through solids. Now this chapter we are going to learn about convection as the method of heat transferring through liquids and gases. Okay children, let's go through this. You may have seen that small twigs of trees above a large fire are waving. You must have seen this, children, right? When there's a large fire, we'll draw it like this. When there's a large fire like this, right? Sometimes if you observe very carefully, if there are branches and twigs of trees above this fire, right above this fire, you must have seen, if you observe carefully, you can see this very clearly, right? You can see they are waving. And at the same time, sometimes you must have seen tiny dust and debris particles also just wave above the fire. Without touching the fire, they just move above the fire, right? Tiny pieces of dried leaves also you can see sometimes. Okay, if you observe very carefully, you will be able to see this. What is the reason for this, children? Now here, I will draw the diagram here again like this. Right. So if we consider the fire like this, right, because of the heat of the fire, right, even though we can't see, everything is surrounded by the atmosphere. Air is present, air particles present. So what happens, children? Right above the fire, air particles get heated up faster. Let's say these air particles get heated up faster because of the heat of this fire. Okay, then what happens? Remember, children, when these air particles get heated up, air rises. Right? Air rises up because of the heat. By absorbing heat, air expands. Right? Its density reduces. Right? Density of this air reduces and the low dense air rises up. So then low dense air particles rises up here. Right? Air present here becomes less dense. Therefore, that less dense air rises up, which means air becomes lighter and rises up. So in this area, this place where earlier air was present, a low pressure area is created because part of the air particles move up. Because of lack of air particles here, a low pressure area is formed here. Right? So when we consider the air pressure, air particles always flow from where it is higher to lower. Right? Air particles spread, or they always move and spread evenly. They distribute evenly. Now, when a low pressure area is created here, low pressure area means a certain area with less amount of air particles. Right? When we consider the surrounding areas, more air particles present. Right? So when you compare with this area, the surrounding area's air pressure is higher. Therefore, what happens, children? In order to make this air pressure even, air flows from the surroundings to this area. Air flows from these surroundings to this low pressure area. Right? Again, that air comes to this area because of the fire, gets heated up again and goes up. Right? Again, air flows from the surrounding to the previous area. So this takes place as air current. Some air moves up from the sides, air comes to that low pressure area. So these currents are known as convectional currents. Right, children? So now you know the reason for the moving of this branch. So when this convectional current, when they go up, when this air moves up, those air that is moving up move these branches and twigs as well. So what can be the reason for this? Due to the convectional current that occurs around this fire, that these twigs and branches move. Okay, children, let's go to the next one. Heated air near the fire rises up and cool air from downwards flows towards the fire. Here, heated air near the fire rises up. I explained y'all the reason for rising up this heated air, because when air gets heated, its density reduces and it becomes lighter. Light air or less weight air goes up, right? So light air goes up, low pressure area is created. To fill this low pressure area, surrounding air flows towards this area. Okay, right. Heated air near the fire rises up and cool air from downwards flows towards the fire, right? Heated air currents rising up like this is called convectional currents, right? Heated air rising up like this is called convectional currents. Okay, children? When these currents strike the twigs of trees, they start to wave. Right, children? We'll move on to the next. We have this activity to do now, finding out how heat travels through the air. Right, I told you all, using these convectional currents, what happens? Using this method called convection, heat transfers through liquids and gases. So we are going to learn how heat transfers through gases. Here we are going to learn, find out how heat travels through the air. Okay. So what do we need to do this activity? We need a tall beaker and we need a piece of cardboard. Piece of cardboard. And we need a candle and some joysticks. We need a beaker, a piece of cardboard, a candle and some joysticks. Okay? We'll see how to do this activity. Cut the piece of cardboard to the shape shown in the figure. Now here you can cut it this way or you can even cut it into a T shape. Right? Place the piece of cardboard in the middle of the beaker to divide the inside of it into two chambers, two parts. Right? So if this is the beaker, right? If you cut this piece of cardboard into T shape, how do you do that? Using the lower T part, you can divide it, right? Right? So if this is the T-shaped piece of cardboard, or you can even use it like this also, right? Using this you can divide, you can place it like this so that it divides the beaker into two sides, two chambers. But you have to make sure the bottom of the cardboard does not touch the bottom of the beaker. There should be a certain space between the cardboard and the bottom of the beaker. Okay, right. First of all, we'll label this diagram, children. Cardboard, beaker, candle, joysticks. Beaker, candle, joysticks. Right, children? Cut the piece of cardboard to the shape shown in the figure Place the piece of cardboard in the middle of the beaker to divide the inside of it into two chambers. Look at the diagram. This side we are going to consider as A, this side as B. Okay? Then place the lighted candle on side B of the beaker as shown in the figure. Right, children? Place the lighted candle on side B as shown in the figure. Light some joysticks and hold them at the mouth of the beaker on the other side, or A, of piece of cardboard. So one side of this cardboard, one chamber of this beaker, you have to light the candle. You have to fix the candle to the bottom and you have to light it up. Right? From the other side, you have to light the joysticks and you have to keep it closer to the mouth of the beaker, upper part of the beaker. Right, children? So light some joysticks. Observe what happens. Right? Now blow out the candle and hold the joysticks inside A. You have to blow out the candle then, and then you have to hold the joysticks again. Right, children? Observe what happens again. Right, children? Okay. First of all, you have to light the candle and then the joysticks, and you have to check what happens, and then you have to blow out the candle and you have to hold the joysticks again next to this part. Okay, let's do this activity. Right, children? By doing this activity, we are going to check how heat travels through air. So here I have a tall beaker. Can you all see I have fixed a candle at one side of this beaker. Observe carefully, it's not in the middle, it's towards the side. Okay, right. Here I have 3 joysticks and here I have a cardboard divider. I'm going to divide this beaker into 2 parts using this cardboard. But when I place this cardboard like this, you all should see this beaker is divided into 2 parts, 2 equal parts, and at the same time this cardboard is not touching the bottom, which means there should be space below the cardboard in the beaker, right? So one side of the cardboard you all can see the candle present, right? So I'm going to remove this one and I'm going to light the candle inside. Okay, first I'm going to light this candle. And with the help of this candle, I am going to light this small candle. Right. Okay. And now I am going to put this divider back. Right, children? And I am going to let it aside. Now what I am going to do is I am going to light these joysticks, right? So one joystick is not enough because we need more smoke to observe this activity well, right? Right. Now observe carefully, where does the smoke go to? You all can see the smoke goes up. Normally the smoke is light and it goes up. You all can see very clearly, right? Now what I am going to do is I am going to place this, I am going to bring these joysticks next to this side of the beaker. Now beaker is divided into 2 sides. One side you all can see the candle. This side, there's nothing in this side. I am going to bring these joysticks over here. Check what happens to the direction of the smoke, right? If you observe carefully, you will see smoke is flowing down this time. Some amount is going up too, But basically earlier you observed that it only went up, it did not go down. Observe carefully, can you all see the smoke goes down, and observe very carefully, the smoke goes under the piece of cardboard and from the candle side it comes up. Now when I take these 3 joss sticks out, look at the direction of the smoke again. Again it goes up. Can you see any amount of smoke going down? No. Right? I will bring it closer to this one again. Observe what happens. The moment I brought it, you see that the smoke is going down again and coming up from the other side. Right? From right under the cardboard. Right, children. What is the reason for this observation, children? This happens because of transmission of heat through air. Now you all know that you can see because of the flame. Now even earlier I explained this one. Because of this flame, because of the candle flame, the air particle above the candle flame get heated up. Right? The heated air is lighter. Where do the light air particles go, children? They go up. Light air always goes up, right? So when the air gets heated up, it becomes lighter. Light air particles go up. When the light air particles go up, what happens? A low pressure area is created inside this part of or just above the candle flame, right? Now air always flows from one place to another place. It always flows from where the pressure is higher to lower. Right, children? So as a certain area with a little lower pressure created just above the candle flame, what happens, children? To fill that gap, air flows from this side under the cardboard to the other side, to the candle side. Okay, now this side air is not heated up because now this beaker is nicely divided into 2 parts. Only this side's air gets heated up because of the candle flame. This side air does not get heated up. Therefore, this side air is cooler than that of this side air. So the hot air goes up to fill the gap created just above the candle flame. Cool air flows under the cardboard and comes up. Then again that cold air particles came right above the candle flame, gets heated up again and it goes out. Up and out. Right, children? So this happens as in a circular way and these are known as the convectional currents. Right? So here what happened? The lighted joss sticks when I brought here, along with the air that goes down and right under the cardboard and that came up, joss stick smoke also goes along with the air. When we kept the joss stick outside, you could see the joss stick smoke only goes up. But when I brought it here, what happens? It goes down. What is the reason? Continuously air current flows from this direction, from outside, this direction, under the cardboard, up through this candle side. So along with air, even though we can't see the air flowing, this is what happens. Along with the air flows inside the beaker and right under the cardboard and outside, joss stick smoke also goes. So this is a very good experiment to observe the convectional currents. Right, children? So you observed what happened. So you all can do even this activity at home very, very easily. Okay, children? Right. So what was the observation, children? So first of all, I lighted the joss sticks. Before I bring the joss sticks closer to this beaker, I ask you all to observe the direction of smoke. What was the direction? When we light the joss sticks, the smoke goes up, right? But when I brought these joss sticks towards this mouth of the side A of the beaker, what happened, children? It still moved up. The smoke still moved up. But after a few seconds, it started to move down, right? Joss stick smoke entered from side A, went under the cardboard, and went out, came towards side B. Right from side B, it went out. Okay, so joss stick smoke enter from side A and goes towards side B. Okay, children? So what was the reason for this one, children? Here what happens? When we light this candle, this side air particles get heated up, right? The air above the candle flame gets heated up and the heated air rises up and goes out, right? So a low pressure area is created here. Earlier I explained you all, when this type of low pressure area is created, to fill that space, to fill that gap, surrounding air comes, right? So the air comes from here. The air present here comes. So then this place becomes empty, and to fill that space, air comes from outside. So when this air flows from outside to inside, along with that air, joss-stick smokes also come inside. Right, children? So this is a very good example of occurrence of convectional currents. Right, children? Let's write this down. Observation. Joss-stick smoke enters the beaker from side A and goes out from side B. Right? Joss-stick smoke enters the beaker from side A and goes out from side B. Okay? What's the conclusion? We will write heated air rises up in side B. Cool air flows towards side B from side A along with joss-stick smoke. Joss-stick smoke. Heated air rises up in side B. Cool air flows towards side B from side A along with joss-stick smoke. Okay, so this happens in order to fill that low pressure area. Okay, children, so this is one example of occurrence of convectional currents. So it can be observed that the smoke of joss-sticks enters the beaker from side A and comes out from side B. When heated air rises up from chamber B, where the lighted candle is placed, cool air flows down into chamber A. Okay? So it's clear that the smoke of joss-sticks also flows with air currents. Thus it is clear that heat travels through the air as convectional currents. Convectional currents. Right, children? So now we are going to do the next activity. Right? So the next activity is finding out how heat travels through liquids. Now here also we are going to prove that heat travels through liquids as convectional currents due to convection. Okay? So what do we need here? We need the purple color Condes crystals. Or this is chemically known as potassium permanganate. Right? We need a candle, we need a Bunsen burner, and a flask like this. This type of flask is known as round bottom flask, or you can even use flat bottom flask too. Right? And then we need a laboratory stand. Okay? We can even use a beaker for this activity. When using a beaker, we can do this activity, children. Okay? So when you dissolve these Condes crystals in water, the water gets purple in color. We did this type of activity during the 4th lesson about solubility of water. Okay, right. Condes crystals. A candle. Burner, Bunsen burner. Round bottom flask. And a laboratory stand. Right, children, we need Condes crystals, a candle, Bunsen burner, a round bottom flask, and a laboratory stand. Okay, so how to do this activity? So look at this diagram. Let's read. Now this is heated water, cold water sinks. Now we will label the other parts of this diagram. This is the round bottom flask, burner, laboratory stand. Round bottom flask, laboratory stand, Bunsen burner. Right, children? Place some Condes crystals at the bottom of the flask and cover them with wax. Right? So you have to take the round bottom flask like this, and you have to place some Condes crystals here. Now you are going to use these Condes crystals for better observation. Now normally also when we heat water, convectional currents occur, but because water is colorless, we can't see them clearly. But we are going to observe the convectional currents occur with the help of the Condes crystals. Now when Condes crystals gradually dissolves in water, it happens according to convectional currents, right? But at the same time, if you did not cover these Condes crystals at the bottom, now we have to dissolve these Condes crystals very little by little. So for this one, we need to cover these Condes crystals at the bottom. Before we do the activity, we need to cover the Condes crystals with wax. So in that case, you can light the candle. When the wax melts, you can cover these Condes crystals with this wax. And when wax solidifies, these Condes crystals will be nicely covered inside. Now you have to pour water to this one, right? Place some Condes crystals at the bottom of the flask and cover them with wax. Okay? Pour water into the flask and heat it. You have to pour water and then you have to supply heat. Then what will happen? Because of the heat, this wax inside will dissolve little by little, right? When this wax dissolves little by little, these Condes crystals will added to water, right? Will get contact with water little by little and it will dissolve in water little by little, and you can see the pattern of these convectional currents very clearly. Okay, pour water into the flask and heat it. Observe what happens. So we will do this activity now. Right, children? Now we are going to observe how heat travels through liquids. So here, in order to do this activity, you all can see I have fixed this round bottom flask. You all can see this flask has a round bottom. Therefore, this is known as the round bottom flask. Okay. So this round bottom flask is fixed to this laboratory stand. Okay. So using this one, we are going to do the activity. Right, children? So we need some water and then we need to deposit some potassium permanganate. Now, potassium permanganate is a very dark color crystals of this chemical. You all can see. Because it's very, very dark color, it looks like it's black in color. but when this potassium permanganate dissolves in water, it gets a purple color. Right, children? So we are going to observe how this potassium permanganate moves through water when we heat the water. But at the same time, whenever we add even a little bit of potassium permanganate to water, it instantly dissolves in water. Therefore, we need to slow down the dissolving of this potassium permanganate in water. It should happen very slowly throughout this experiment. Then only we can observe how heat transfers through water. Okay, children? Therefore, I am going to wrap some potassium permanganate using this piece of lead. Okay? So, how do you do that? Take a little bit of potassium permanganate to this type of piece of lead, and then you have to nicely wrap it. Right? And then now you need to deposit this part in the bottom of the water. But at the same time, you should leave little spaces so that potassium permanganate can slowly come out of this cover. Okay, children? So in that case, you have to make tiny holes using a small pin. So after making the tiny holes, all these holes, the entire setup, entire pocket-like part should be covered with wax. So for that, you can light a candle, and when the wax melts, what you can do, you can nicely cover the entire setup with this pocket-like part with wax. Okay. So here I have made a small pocket-like that I explained before earlier. Otherwise, there's another way to do this activity. We can straight away deposit this, place some of these potassium permanganate crystals in the bottom of a dry round bottom flask. You can even use a beaker for that. And from there, you can cover this potassium permanganate by pouring some melting wax onto this round bottom flask. Right? Either way, you can do this activity. Okay, children? Let's do this activity now. Right, children. Now I have filled this round bottom flask with water. Now we are going to put this potassium permanganate containing packet into this water. Okay. Right. You all can see it went into the bottom. Okay. Now what we are going to do is we are going to start heating up this setup. Right. Now observe very carefully what happens, children. Now you all know that potassium permanganate covered with this piece of lead, and at the same time nicely covered with wax is at the bottom. So when you heat this water up, what happens? This wax starts to melt, and thereby potassium permanganate can slowly come out of this packet. Okay, children. Now then observe what happens, how it moves through water. Water is getting heated up at the moment, right? Now look very carefully. You all can see nicely that potassium permanganate from the bottom, from the middle part of the bottom, it goes up. When it comes up, look what happens. Observe carefully. It comes up, and from the sides, it will start to go down again. From the middle, this potassium permanganate, the purple color, rises up, and from the edges, from the wall side of this round bottom flask, it goes down again. You have to observe this very carefully. From some parts, you wouldn't be able to observe it very clearly, but if you observe carefully from certain edges, you can see it goes up then it goes to the sides of this vessel, and then it goes down from the edges. So the color goes up from the middle. So observe carefully how that happens. So thereby, gradually the color of potassium permanganate spreads through water. It started from the middle, from the bottom part, from the middle. Okay? And it gradually spreads up and then to the sides and again back to the bottom. So earlier, the middle part was purple in color. The surrounding was still colorless water. Okay? But now you can see when these current-like parts occur continuously, this potassium permanganate's purple color spreads throughout the water. Okay? If you observe carefully, you can see tiny air bubbles coming up from the bottom to the surface. Right. And more color of potassium permanganate coming from the bottom, middle part, spreading towards the edges. Thereby the purple color of this solution increases. But it did not instantly spread out throughout this water. Right? It took time. Only the middle part first got the color of this potassium permanganate, then slowly the edges got colored. So you observed what happened. Sometimes you can't exactly observe these current-like parts, but you clearly observe when this potassium permanganate, which was in the bottom, came up through the bottom middle part. Thereby only the middle part got colored first. Slowly the outer parts got colored. This means the color of the potassium permanganate spreads throughout the water like a current. So why does this happen, children? Now this potassium permanganate moves through water along with the water particles, right? So when you heat this water, now here you all can see at the bottom, this we supply heat from the bottom of this vessel. So then what happens, children? The bottom part of this, the bottom middle part of this water gets heated up faster than the surface, right? So when these liquid particles get heated up, what happens, children? The density of these liquid particles reduces. Therefore, these low dense particles go up, right? Heated water particles go up. So the water present in the upper part is cooler than that of the bottom. Therefore, that is heavier than this heated water, right? So the heated, less heavier water particles come up, and then the colder water particles, this is heavier than the other water, heated water, it goes down from the edges. This takes place as a current, and these types of currents are known as convectional currents. So whenever we heat water, water gets heated up because of occurrence of convectional currents. So why did we use potassium permanganate here? Normally if we boil water, whenever we boil water, this is how the water gets heated up. But we use potassium permanganate to observe this better. Right, children? So you observed what happened. So we placed some Condes crystals in the bottom of the flask, right? And we covered it with wax, and then we filled the vessel with water, and we started to heat the water vessel slowly. Then what happened, children? This wax melts little by little, and Condes crystals, you could see Condes crystals from the middle, it starts to come up, right? The color of the Condes crystals, purple color, rises from the middle, and from the sides of the walls, from the wall sides of this round bottom flask, it goes down and it comes down again, right? You could see it as a current. It goes up from the middle, it comes down from the sides, again goes up from the middle, comes down from the sides. Why does this happen? Now when you heat water, the same way, when we heat water, what happens, children? the water particles present at the bottom gets heated up first, right? Heated water becomes less dense. The density of heated water reduces. So compared to the upper part and lower part's density is less. Upper part's cold water's density is higher, right? Cold water's density is higher. Therefore, less dense water particles go up, and at the same time, when less dense water particles go up, it pushes that high dense water particles down. Because of the density, they sink down, right? Again, when they come down, they get heated up, and again, they move like that, right? They get heated up, becomes less dense, go up, and meanwhile, the particles which went up earlier gets cooled down and again comes down, right? This happens circularly, and by this method, heat spreads throughout the entire mixture or the solution. Okay, children, we will write this down. Purple color of Condes crystals rises up from the middle and sinks down from the side as a current. Right? Purple color of Condes crystals rises up from the middle and sinks down from the sides as a current. Right? Why does this happen? We will briefly write the reason. Right? Water particles at the bottom get heated up and become less dense. These less dense water particles rise up from the middle. More dense cold water particles go down from the side. Gives rise to convectional currents. Right, children? Water particles at the bottom get heated up and become less dense. The less dense water particles rise up from the middle. Right? Less dense means weight is also less. Because their weight is less, they go up. Right? More dense cold water particles. Cold water particles are denser than the one at the bottom. So they are heavier, they come down. Right? Go down from the sides. This gives rise to convectional currents. When this happens as currents, these currents are known as convectional currents. Okay, children? So it can be observed that the purple color rises up as currents from Condy's crystals in water and sinks down near the wall of the flask, right? Here, water at the bottom of the flask is heated and rises up because of the reduction of its density. Meanwhile, cold water at the top sinks down because of its higher density, right? Rise in heated water currents and sink in cold water currents are known as convectional currents, right? Convectional currents. Water in the flask heats because of these convectional currents, right? Here actually what happens is, let's consider. So when we consider a liquid, what is the particle arrangement, children? There are spaces between particles, right? There are spaces between particles. Okay? There are spaces between particles. So the particles, liquid particles at the bottom, when they get heated up, what happens? From the middle, when these liquid particles get heated up, then what happens, children? These heated particles move up. These heated particles move up, right? Because they become less dense, right? Heated particles move up and the water particles present. Now, when waters move in, what happens? Waters move in means water particles also move, right? Heated water goes up, cold water comes down as currents. Right, children? So here what happens? In this convection method, now earlier we learned about conduction, we learned that heat transfers from particle to particle through solids, but particles do not move. Particles remain at the same place. But when you consider this method called convection, heat transfers through liquids and gases, but at the same time, particles also move along with heat. Right, children? So the method of transferring heat through liquids and gases by convectional currents is known as convection. So if in any medium, convectional currents occur when heat is provided, the method of transmission of heat through them is known as convection. So what are the two methods that heat transfers by this method? So, liquids and gases. Okay, children? We'll move on to the next. So we have this assignment to do. Make toys operated by convectional currents and display them in classroom. So even at home you can do it very easily, right? I will give you one example how to do this one, children. So you can take a piece of cardboard like this. You can draw a spiral, right? You can draw a spiral shape, right? You can draw a spiral shape like this. Right, and you can cut this spiral shape along the lines. Right, you can cut the spiral shape along the lines. Right, and you have to take it off this piece of cardboard. Right, and from one end you can hang this. Now from this middle part you can hang it with tie it up with a thread. Right, so if this is the thread, from this middle part you have to tie a thread and you have to hang it. Right, when you hang it, you will see something like this, a spiral shape like this. What you have to do now is you have to hang it somewhere in a, if you do it at school, you can hang it on a laboratory stand. And under this, you can light a candle and observe what happens. Right, children? So you will realize that after a little while, this spiral shape design starts to rotate. Okay, it starts to rotate. Okay, children, why does that happen? When you light this candle, the air above this candle gets heated up and move up as convectional currents. Because of the air that is moving up, this spiral shape starts rotating. Okay, children? So this is an activity. The same type of activity you can do. You can make a small propeller, very light, with something lightweight. You can make a small propeller and you can again light a candle under this propeller. And after a few seconds, when you observe, this propeller will start to rotate. Okay, children, this propeller will start to rotate when you light a candle underneath. Okay, children, we'll try to do this activity in the lab now. Right, children? So as I explained you all before, we are going to use some toys that work with convectional currents. Okay? So here I explained you all how to make this type of spiral shape, and you have to tie it from the middle like this. Okay? And here I have these two candles. I'm going to light both of them so that because of the high heat, we can make this work effectively, right? Okay. So at the moment it's not moving. Observe what happens when I keep these two candles under this spiral shape, okay? Right, children? So did you observe? When I take it away, after a little while, it will stop moving. Right, children? Right. When I place this under, it starts moving to one side like this. Okay, children? So what is the reason for this, children? That is because of the convectional currents, right? When the air above this flame gets heated up, that air goes up as convectional currents. Because of that moving air up, it makes the shape rotate. Okay? So in the same way, we can use this type of propeller connected to this wire, tiny rod. So it's not moving at the moment. Observe what happens. Okay, children? So it's slowly moving. Right, children? This also happens because of the same reason. Because of this flame, right? The air layer above this flame gets heated up, and what happens, children? Heated air becomes lighter and it goes up. Because of the air that is moving up, we can make these type of toys work. Right, children? So I hope you enjoyed those two activities, and I think you can design other activities also similar to them. Okay, children? We'll move on to the next. Now we are going to learn about the application of convectional currents. Okay? So we are going to learn about occurring of sea breeze and land breeze. First, we are going to learn about sea breeze. If you go to a coastal area, if you go to the beach during the daytime, what would you feel? You will feel the breeze on your face. Okay, children, this is sea breeze. How this sea breeze? Sea breeze means the breeze that comes from the seaside to the land side. Okay, this is called the sea breeze. How does this sea breeze occur, and what is the relationship between the convectional currents? We will see. Right? The wind that blows from sea towards the land is known as sea breeze. Right? Sea breeze occurs in the daytime. During the daytime, now look at this picture. This is the sea, this is the land. Okay? So during the daytime, because of the sun's heat, both land and the sea gets heated up. Land also gets heated up, seawater also gets heated up. But when you consider the land, it's solid and seawater is liquid. So the solid part gets heated up faster. Therefore, the temperature of this land is higher than that of the seawater. Right, children? So when you compare the sea and the land, this part gets heated up. The land part gets heated up faster. Okay, so when this part gets heated up faster, what happens, children? So when you consider the air, right, air next to this land also gets heated up and hot air rises up. Right, hot air or heated air rises up. Now we know what happens, right? Now this area becomes a low pressure zone. In order to fill this low pressure area, right, less pressure area, wind comes. So air comes from seaside to the land side, right? This wind or air comes from the seaside is known as sea breeze. Okay, so sea breeze occur in the daytime. During the daytime, land area heats faster than the seawater because of the solar heat, right? The land area absorbs heat faster. Okay, children? This causes the layer of air contact with the land to heat and rises up as convectional currents. Now, these are the convectional currents. Okay? To fill the low pressure area created on the land, air currents flow from the sea towards the land. This is known as sea breeze. Now, this is sea breeze. Convectional currents. Convectional currents. This is the low pressure area. Right, children? So during the daytime, land gets heated faster than that of seawater. Therefore, the air next to the land gets heated up and it rises up as convectional currents. So that low pressure area is created next to the land, and to fill this low pressure area, wind comes from the, or air comes from the seaside, and that is known as sea breeze. Okay, children? So we are going to watch a video on sea breeze now. Right, children? After watching that video, I hope you understood what sea breeze is better. Okay? We'll move on to the next. Right. So the next one is land breeze. Now this land breeze is the opposite of sea breeze, children. Right? Land breeze is the opposite of sea breeze. We will go through this one. The wind that blows from the land towards the sea is known as land breeze. The wind that blows from the land towards the sea is known as land breeze. Right? So the land breeze occurs at night. During night time, the temperature of the land area decreases faster than the seawater. So during the daytime, both land and the seawater gets heated up due to sunlight. During the night time, there's no sunlight. Therefore, what happens? The heated surfaces release its heat during the night time. Right? During the daytime, objects absorb the sun's heat. During the night time, these objects release the sun's heat. right? Now, when we consider about the rate of releasing this heat, land releases heat faster than that of seawater, right? So land releases heat faster, which means when you compare the heat of the land and the seawater, land is colder than that of seawater. Temperature of seawater is higher than that of land during the night time. Then what happens when you consider the same incident happens in the sea now, right? Now when you consider the water's temperature is higher because of that, by absorbing heat of the seawater, so the air layer next to the sea gets heated up and it rises up as convectional currents. Right now we know that heated air rises up because it becomes less dense. Right? A low pressure zone is created on the surface of the sea now. Therefore, to fill this low pressure area, wind or air comes from the land side. This is known as land breeze. Okay, children? So land breeze occurs at night. During night time, the temperature of the land area decreases faster than the seawater because land releases heat faster. Land can absorb heat faster, releases heat faster too. Okay? Therefore, the land area cools faster. Because of the high temperature of seawater, the layer of air contact with seawater gets heated and rise up as convectional currents. Okay? To fill the low pressure area created on the sea, air currents flow from the land towards the sea. This is known as land breeze, right? This is land breeze. Now these are the convectional currents. Convectional currents. And this is the low pressure zone. Right, children? So land breeze, it occurs at night time and it flows from the land towards the seaside. Sea breeze is the opposite, occurs during the daytime, and the sea breeze flows from the seaside towards the land side. Okay, children? So for extra knowledge, it's given. It's with the support of the land breeze that fishermen launch their sailboats to the sea in the night time. They return back to the shore in the daytime with the support of sea breeze. So during the night time, if this is the sea and if this is the land, right? During the night time, they always launch their sailing boats. Why? What is the reason? Because they can get the support. They have to use less energy in order to launch their boats because the breeze is always towards the seaside during the night time. Right? So when they have to go to sea to catch fish, then what happens? It's easy to go in the night time because they get the support of the sea breeze and they don't have to put much effort. Okay? So during the daytime, in the morning, when sea breeze present, they can come back towards the land side with the help of the sea breeze. Okay, children, so this is the land breeze, and with land breeze, they go catching fish, and in the morning with sea breeze, with the help of the sea breeze, they come back to the shore. Right, children? We'll move on to the next. So we have this assignment to do now. Prepare a list of other applications, important occasions associated with convectional currents. Right? Formation of wind occurs because of these convectional currents. Okay, formation of wind occurs, formation of monsoon winds, due to the formation of monsoon winds, monsoon rains, right? Because during winds, the wind brings the clouds also in that particular area, the clouds are brought, rains occur, right? Occurrence of monsoon winds and rains, right? We will write. Occurrence of monsoon, wind, and rain. What else, children? occurrence of water currents, right? So occurrence of water currents also occur in the sea, also occurs because of these temperature changes and because of convectional currents take place in water. Okay, occurrence of water currents. Now water currents occur when the polar regions temperature is lower than that of the equator area of the seas, right? Then what happens, because of the temperature difference of these two different types of water flows from one place to another place as convectional currents. Okay, so water currents. Water currents occur in the ocean. What else, children? So if you read articles and if you refer to the internet, you will find more examples like this. Okay, so day-to-day activities also we need the application of these convectional currents, right? To boil water, water gets boiled because of the convectional currents, right? To boil water. To boil water. Right? To cook food, right? Let's say that when you cook certain vegetable with water, so due to the convectional currents, heat is transferred throughout the entire mixture. Okay, children, so in day-to-day activities also we need to use the convectional current. So for this one, you can make a report and you have to find your own examples. Okay, children, find more examples, read more articles, you can refer to the internet, you can go to the school library and you can find more information on the use of these convectional currents. So we have completed this chapter as well. So under this chapter, we learned another method of heat transfer called convection. Now we know that convection is the method of heat transfer through liquids and gases, and here heat transfers by moving the particles of liquids and gases. So in the next chapter, we are going to learn about radiation, the last method of transferring heat.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.